Today we're going to talk about a very special number, and that number is the natural exponent, or more commonly known as e. To talk about this though, what I really want to explore is just a hypothetical situation. Let's say that you are lucky enough to find a bank interest account that is offering you 100% interest. And what you're interested to really know about is how much money are you going to be getting back for every $1 that you invest? Now, to explore this, let's just say that we're investing our $1 here into a bank account that is compounding annually. So to find our future value, or how much we'll get in return for our $1 investment, we would have to do our $1 multiplied by 1 plus our interest rate. Now, interest rate's 100%, so that's going to be 1. And then that's going to be raised the power of how often it compounds, which annually it'll compound once. Now, when I put that in, I'll find that I'll get a $2 return. Now, that's absolutely awesome. For my $1 investment, I'm getting a $2 return. And that makes sense if I'm getting 100% growth for every one time period. But we know through the work that we've done with our financial maths that the more often something compounds, the greater the return that we get. So just how much of a return can I actually get for my $1? Well, to explore that, let's start looking at changing this to more frequently. So we'll go with biannually next, which will mean that our interest is going to compound twice per year. So to find our future value, we would have to do our $1 investment, but this is just 1 times whatever's here. So I don't really need to write this 1 here at all. But it's going to be my $1 times my 1 plus my interest rate, and I've still got a 100% interest rate, so that's 1. But this time the interest rate's getting divided up twice per year. It's getting applied twice per year. So we'll have to divide up our interest rate into the twice that it's getting applied. And then of course it needs to be raised to the number of times it's going to compound, so to the power of 2. And if I put this into my calculator, I'll find that I'll get a return of $2.25. Which is fantastic. That's 25 cents more than what I got previously. So my thought's this: is there actually a way, if I continue increasing how often it's compounding, that I can get an unlimited return for my money? Well, let's continue this. Let's go to monthly. Now, with my monthly, what will change here is, my future value is equal. I'll still have my 100%, but this time is going to be divided between my 12 months, and then it's going to compound 12 times. Now, if I put this into my calculator, it'll get me a return of approximately $2.613. I'm going to start rounding to more decimal places so we can see exactly what's going on here. Now, just looking at this, I've had, a fairly substantial growth here from what I had last time. Maybe not as much as what I was hoping for, but, so far so good. It seems like if I continue increasing this is just going to continue growing larger and larger. So what if I could go more than monthly? What if I could convince my bank account to, rather than compound monthly, compound daily for me? Well, for a daily compounding, my future value will be 1 plus, this time it will be over the 365 days there are in a year, and then it's going to compound 365 times. So how much of a return will I get for daily? Well, when you put that into your calculator, it'll be approximately 2.71457. So the growth that I've seen here, despite it compounding so many more times, seems to be nowhere near as much as what I was getting earlier. Well, I'm not beat yet. I can take this further. What if, instead of looking at daily, let's go to hourly. Surely that'll make a big difference here. Well, for hourly, our future value will be equal to 1 plus 1 over, it will be my 365 multiplied by 24 hours that there are in each day, all to the power of 365 multiplied by 24. And now, when I go and put this into my calculator, it'll be approximately 2.718127. And it's just not the increase from here that I was hoping for. But I'm not beat yet. Let's not compound this hourly. Let's take it a step further. Let's compound it minutely. Now, I'll be honest at this point, I don't even know if minutely is a word, but hey. So to do this, we will do 1 plus, it'll be 1 divided by 365 times 24 times 60 for every minute there is in an hour, all raised to the power of 365 times 24 times 60. And now when I go and put this into my calculator, it gives me approximately 2.718128. So what's going on here? Well, it doesn't seem to matter that I'm substantially increasing how often this is compounding. How much is going up by just doesn't seem to be going up anywhere near as much. And what we're experiencing here, this number that it seems to be approaching, is a value that's very special. It's the value that we refer to as E, an irrational number. So if we were to take this one step further and go, you know what, let's not do this minutely, let's do it infinitely, so continuously. So this is now compounding an infinite number of times. Now, I know that infinite isn't a value, it's more of a concept, but if we were to continuously compound, how much of a return would I get? And that return would actually be equal to E dollars. Now, if you want an approximation for E, well, it's approximately 2.718128, and it just keeps going and going forever. It's an irrational number that keeps going forever. But what I'm really experiencing here is the maximum value that I can get in return for a 100% growth when it's continuously compounding over one time period. And that is what the value of E represents. So the value, or the constant E, is representing the maximum value that can occur if you are continuously compounding with 100% growth over one time period.